Alright, so in this video, we are going to start chapter 6. And chapter 6, we are going to talk about integration. So chapter 5, we talked about differentiation, and we talked about the different ways to differentiate a polynomial function. We talked about the chain rule and everything. And now it's the other part of calculus. So we talked about two big parts of calculus, differentiation. And the next part is going to be integration. And we are going to start with indefinite integrals. So indefinite integrals, basically, we mean, when we say indefinite integrals, we mean that there are no bounds. There are no bounds. So you just have a function and you solve the integral. So this symbol, this long S-like symbol, is the integral symbol. So for derivatives, we use d by dx. For integration, we will use this symbol. That is the integral symbol. And we are going to find the integral of a function with respect to dx. All right. So now, if it's a definite integral, another type that we will encounter later, then we will be integrating from some value a to another value b. So this is a definite integral. All right. And an indefinite integral, we have no bounds. We are just integrating from we don't have bounds. We are just integrating a function with respect to dx. So this is an indefinite integral. Alright, so now that we have looked at the difference between a definite and an indefinite integral, let us look at the fundamental theorem of calculus. So according to the fundamental theorem of calculus, we have the following. So the integral of this function, right? So the integral of f of x dx is going to be some capital F of x. And this f of x has the property that if you differentiate f of x, you are going to get this. So basically, if you integrate the small f of x with respect to dx, you get another function. And this function is going to be capital F of x. And this new function, capital F of x, has the property that if you differentiate capital F of x with respect to x, so if you do d by dx of this capital F of x, then you have to get the inner function here. So now, what if I add a constant value to this, right? So what if I add a constant value to this? And if I differentiate my right-hand side, then d by dx of f of x, we talked about this, is going to be our small f of x, right? The inner function. And d by dx of c is just going to be 0. So we have small f of x. So basically, when we take an indefinite integral, when we do an indefinite integral, we are going to get a function capital F of x, and we can add any constant to it. And it's still going to satisfy the fact that if I differentiate the right-hand side, I am going to get my inner function on the left-hand side. So that is the idea. And the main idea is that integration and differentiation are reverse processes. And what do I mean by that? Well, if I have f of x, and then I integrate it, I get capital F of x plus any constant, right? If I take this, I differentiate it, I get small f of x. So basically, it undoes. And the other way works as well, right? If I differentiate f of x, I might get f dash of x, right? And if I integrate f dash of x, I will get f of x plus c. So basically, the idea is that integration and differentiation are reverse processes. And now we are going to use that. That is the fundamental theorem of calculus. The fundamental theorem of calculus just tells you that integration and differentiation are reverse processes. All right. So if you have something like, say, you have d by dx of f of x, that is going to be f dash of x, right? So if you integrate f dash of x with respect to dx, So this is the how you express an integral with respect to dx. So this has to match with the inner variable x. Then that gives you f of x, and as we have discussed before, you can add any constant c to it. And similarly, if you're integrating a function f of x dx, you get capital F of x plus c, and if you differentiate capital F of x plus c, then you get your small inner function f of x plus 0, which is just going to be f of x. So that is the idea. The fundamental theorem of calculus tells you that taking the integral is the reverse process of taking the derivative, and vice versa. So that is why sometimes instead of saying integration, they will tell you to find the antiderivative. So sometimes integration is also known as finding the antiderivative. Alright, so now that we have discussed that, for derivatives, we had the power rule. So d by dx of x to the power n is n x to the power n minus 1. For integration, we have this rule. So if you're integrating x to the power n dx, then what you are going to do is you are going to increase your power by 1, and you are going to divide by your new power plus c. So we are going to be using this formula. And again, try to differentiate your right-hand side. Well, if you differentiate plus c, because c is a constant, you are going to get 0. So you only need to evaluate this part, right? And remember, 1 over n plus 1, that is the constant that we can factor out. So we actually only need to calculate this. N plus 1 is a constant, so you can just take it out of the derivative operator. So you have 1 over n plus 1. If you differentiate this, you get n plus 1 x to the power n, right? You bring your new power down, you decrease the power by 1. These cancel out, and you get x to the power n. And remember, x to the power n is your inner function. So you can see, you do forwards, you do integration, you get some result, you differentiate that result, that should be your inner function, f of x. That should be the function that you integrated to begin with. Alright, so this is the one rule that you want to remember. And remember, n cannot be equal to -1. If n is equal to -1, your denominator becomes 0, and that is not possible. So what if n is equal to -1? So what if you have integration of this thing, right? So this is integral of 1 over x dx. How do you solve this? Well, this is going to be ln modulus x plus c. So although I don't think this is covered for this year, but that is, if your n is -1, then this is going to be your answer. And this comes from the fact that if you differentiate ln x or ln modulus x, it's the same result. You get 1 over x. Alright. So I don't think you need to know this, but this is just to tell you what happens when n is equal to -1. If n not equal to -1, we can use this formula. And this is the only formula that we are going to be using for the grade 11 level. Alright, so now let's go over more rules. So let me write down the most important rule that we were going to use is that the integral of x to the power n with respect to dx. Always with respect to the variable. D times dx just means a very, very small change in x. And we are going to look at the geometric meaning of integration in a future video. When we get to definite integrations, we will definitely look into what this expression, the dx, how it comes from, and so on. But for today, let's just accept that you have integral of x to the power n and dx, right? So that is how we are going to express it. We are always going to integrate with respect to dx, or d of the variable concerned. So this is x to the power n plus 1 divided by n plus 1 plus c, the most important formula. And we add this plus c because whatever constant you add, whenever you differentiate the right-hand side, you are still going to get x to the power n. So this constant doesn't matter. So you actually have an infinitely many functions, right? You have a family of curves that when you differentiate, you are going to get your inner function. So that is just what we are trying to say. There are infinitely many solutions that, when you differentiate, you get this value, right? So by definition, you have infinitely many integral solutions, right? There are many solutions that just differ by some constant. Alright. So now you have this. Now what happens if you integrate f of x plus or minus g of x dx? And integration is a linear operator. So that means it's just integral of f of x dx plus or minus integral of g of x dx. And similarly, if you have integral of k f of x dx, you can just factor out the k. So this just means that the integral operator is a linear operator, but we will not get into that, just like the derivative operator. So the same rules also hold for integration here. And that is all that you need to remember. That is almost everything that you need to know for this entire chapter. All right, so now let's start with the questions. So I am not going to do all of them. Sorry, I think I started at the wrong page. All right, I am not going to do all of them. So I'll just do them alternatively. So for question 1, I'll do B, D, and E, and F. For question 2, I'll do A and C. For question 3, I'll do A, C, D, and F. All right, so that is how we will go. So I won't do all. So the ones that I don't do, I hope that you will try to do it on your own. So what did we previously discuss? We discussed that the integral of f dash of x dx is just f of x plus c. If you differentiate the right-hand side, you are going to get your inner function f dash of x, right? If you differentiate the right-hand side, you are going to get f dash of x. All right. So basically, f dash of x is just dy by dx. So what is dy by dx? dy by dx is given. It is this expression, 14x to the power 6. So that is going to be my antiderivative, f of x plus c. All right. So basically what I need to remember is that I need to get some function and I need to add some constant to it. So let's solve this. 14, I remember I can factor out. So I can just integrate x to the power 6 dx. Now let's use the rule. The rule said that, hey, if you have x to the power n and n is not -1, then you can increase the power by 1 and then divide by the new power. And then you need to add plus c. All right, so that is what we will do. X to the power 6 plus 1 divided by 6 plus 1 plus c. So we have 14 times x to the power 7 divided by 7 plus c. So that is going to give you 7x to the power 7 plus c. All right. So that is the solution for... Sorry, 14 divided by 7 is 2x to the power 7 plus c. All right, 14 divided by 7 is going to give you 2x to the power 7 plus c. All right. So that is the solution for part B. And now we will erase this. I hope that is okay. So we are given dy by dx for d is 3 over x squared. Now remember, dy by dx is just f dash of x. And we want to find that, what does the question ask? We find y in terms of x, which just means find f of x, right? Because y is going to be f of x. So we just need to find f of x. So this can be written, this is just f dash of x, this is this expression. Now, this is not -1, so we can use the formula. So f of x is just going to be the integration, or what we can do is just we can integrate f dash of x dx. So that means we integrate this expression with respect to dx, right? We integrate both sides with respect to dx. And on my right-hand side, on my left-hand side, I am going to get f of x. And basically, yes, there is a constant, but we can assume that we just add the constant to the other side, and constant plus constant or constant minus constant is going to give me some other constant, which I don't care about. So we have 3 integral of this expression, right? I just take the 3 out, and now I can use the formula. 3 x to the power minus 2 plus 1 divided by minus 2 plus 1 multiplied, right? Plus c. So minus 2 plus 1 is -1. So you will get 3x to the power minus 1 plus c. And, right, minus 2 plus 1 is -1. So x to the power -1. The denominator is -1. And 3 divided by -1 is -3. So you are going to get -3 over x plus c. That is your solution. F of x is -3 over x plus c. And we are done with part D. and part f. So you have dy by dx, and you can always check your answer, differentiate this answer, right? So in the future, when we do more complicated integrals, then it's going to be hard to differentiate the answer. But for your grade 11 level, always differentiate your answer if you have time to check. So plus c, if you differentiate, that's a constant, you're going to get 0, right? The derivative of a constant is always going to be 0. So in case I didn't mention, but for any constant, the derivative is going to be 0. So now you're taking 3 out, d by dx of minus 1 over x plus c is just plus 0, right? Differentiation of the constant. So now if you differentiate this, you are going to get 1 over x squared. If you differentiate this, you are going to get minus of minus 1 over x squared, so plus 1 over x squared. And finally, your answer is going to be this, which is what we started with, right? Here. So if you differentiate and check, you will see that your answer exactly matches what you started with, which was this. All right, so this is y. And now let's do f. F is dy by dx is equal to 4 over root x. So another way that you might be shown how to do it is that you might be told to multiply by dx on both sides. And we get this expression. And now if you integrate dy, and you can integrate 4 over root x dx. And basically, dy just means you have very, very, very small pieces of y being added together. The integration operator adds things together. You are adding infinitely many small pieces of y. So if you add them together, you are going to get y. And you can factor out a 4, and you can integrate this expression, right? You brought out a 4, and you wrote 1 over square root of x as x to the power negative half. And now you can write this as negative half plus 1 is going to give you positive half, divided by your new power, plus c. So your final answer is going to be 8 root x plus c. So that is your answer. So from here, what I did was x to the power minus half plus 1 divided by minus half plus 1, right? My denominator, if you do minus half plus 1, which is 2 plus 2, I am going to get half. My numerator, I am also going to get half. So that is just 2 root x. So you can actually remember that the integral of 1 over square root of x dx is just 2 root x plus c. So that is something that you can remember. All right. So our final answer is just 8 root x plus c. So that is one way that you might learn how to integrate this function. So you can learn it maybe as a differential, very easy differential, separable differential equation, but the idea is the same. So we are done with question 1. All right, so let's do question 2. It says, find f of x in terms of x for each of the following. So it's the same question. For question 1, we had dy by dx. For question 2, we just have f dash of x. If you integrate f dash of x with respect to dx, you get f of x plus c. You have 5x to the power 4 minus 2x to the power 3 plus 2, right? All right. So now, f of x, you are going to obtain when you integrate this expression, when you integrate f dash of x with respect to dx. So how do we solve this? Well, we do it individually. So the sign in the middle gets preserved. And remember, you need to add a dx to every integral. So it's going to look like this. This sign came here, this sign got preserved here, and then the dx got distributed to every term. And so we have this. Now what can I do? Well, here, I can factor out a 5. And I have x to the power 4 dx. Here, I can factor out a 2. And I have x to the power 3 dx. And here, I just have an integral of dx. And now one way to think about it is integral of dx is just going to be x. And again, all of these integrals will have a constant. We are just going to add together constant and write it as one big constant at the end. Or another way to think about it is you have x to the power 0 dx. And because 0 is not equal to negative 1, you can write it as x to the power 0 plus 1 divided by 0 plus 1 plus c, which is just x plus c. So those are the two ways to imagine it. Because you can write dx as 1 times dx. And 1 is just x to the power 0. That is another way to write it. So you have 5 times x to the power 4 plus 1 is 5 divided by 5 minus 2 times x to the power 4 by 4, right? I just increased 3 by 1, increase the power by 1, divide by the new power, and 2x plus a big constant c. So 5 and 5 will cancel out. You have x to the power 5 minus half x to the power 4 plus 2x plus c. That is your solution to A. And now, let's do C. C is f dash of x is equal to 2 over x cubed plus 8 over x squared plus 6x. So now f of x is going to be 2 over x cubed plus 8 over x squared plus 6x with respect to dx, right? It's the same idea. I just have to integrate my derivative function and I get my f of x. All right, so I can write this as 2 over x cubed dx plus integral of 8 over x squared dx plus integral of 6x dx. All right, so now I can factor out a 2 and I have this integral. I factor out 8, I have this integral. I factor out a 6, I have this integral. The third one is easy because it's just x to the power 1. I can easily apply the power rule. 1 over x cubed, I can write it as x to the power minus 3. 1 over x squared, I can write it as x to the power minus 2. So now we are going to integrate. 2 times x to the power minus 3 plus 1 is minus 2 divided by minus 2, right? You have to divide by the new power. Plus 8 times x to the power minus 1. Minus 2 plus 1 is negative 1. I need to add 1 to the power, and I need to divide by the new power. Plus 6. X 1 plus 1 is 2 divided by 2 plus big C, containing all the constants together. So here you are going to get negative 1 over x squared. Because this 2 and this 2 cancel out, you have a negative sign, and x to the power minus 2 is 1 over x squared. And from the second term, you have 8 over x. And from the third term, you have 3x squared plus c. And that is going to be your solution, right? 6 divided by 2 is 3, x squared plus c. Here you get negative 8 over x, and here you get negative 1 over x squared. So that is your solution. So you can also write this as 3x squared minus 1 over x squared minus 8 over x plus c. It's the same expression, I believe. Yeah. All right, so we are done with C as well. So this is your solution, whichever expression you write, to C. And we are done. And question 3 is essentially the same. We want to find in terms of x, y in terms of x. So we are given a dy by dx is equal to, let me multiply this out. I get x squared plus 5x. And now I can say, hey, dy is x squared plus 5x. This is the derivative function times dx. Now I need to find y, I just need to integrate both sides. So if I integrate dy, I get y. If I integrate my right-hand side, I am going to get integral of x squared plus 5x dx. And now I can do it separately. I can do integration of x squared dx plus integral of 5x dx. What is the integral of x squared dx? Well, x, you raise it to a new power. 2 plus 1 is 3, and you divide by your higher power, your new power, right? Plus 5 integral of x dx. And x cubed over 3 plus 5 x, this is x to the power 1. 1 plus 1 is 2, divided by 2 plus c. So always remember, if it's indefinite integral, if there are no numbers here, you always want to add plus c at the end. So that is something to keep in mind. So your final answer is going to be 1 over 3x cubed plus 5 over 2 x squared plus c. That is your solution to question 3a. And we are done. Let's do 3c. So we have dy by dx is equal to x plus 2, x minus 8. So let's just expand out the brackets, right? You have x. If I expand these two terms out, I get x squared minus 8x plus 2x. So x squared minus 8x plus 2x minus 16. And that is x squared minus 6x, right? If I simplify here, minus 16. And if I multiply by x, I get x cubed minus 6x squared minus 16x. So now I know what dy by dx is. So now dy is going to be x cubed minus 6x squared plus minus 16x times dx, right? And therefore y is going to be the integral of x cubed minus 6x squared minus 16x dx. And now I can do this separately. I can do x cubed dx minus 6x squared dx minus 16x dx. All right, so this is going to be 1 over 4 x to the power of 4. How? Use this formula that I told you. N plus 1 divided by n plus 1 plus c. So in this case, n is equal to 3. So you have x to the power of 4 divided by 4 minus, you can factor out is 6. Minus, you can factor out is 16. So it's you can take out the constant, not factor out, but you can take out the constant from the integration sign. So now this is just 1 over 4 x to the power of 4 minus 6 times this is x to the power 3 by 3. Increase the power by 1 and you divide by your new power. Similarly, you have 16 times x to the power 2 by 2 plus c. Don't forget your constant because it's an indefinite integration. So x, you have power 1. So you increase your power by 1, you divide by the new power. So you get 1 over 4 x to the power 4 minus 2x cubed minus 8x squared plus c. And that is your solution. So these are the solution for A and C. And now let's do D and F. All right, so let me erase everything. I hope that is okay. So for part D, we have dy by dx is equal to x to the power 4 minus 2x plus 5 divided by 2x cubed. So let's simplify this a bit. I can write this as x to the power 4 divided by 2x cubed minus 2x divided by 2x cubed plus 5 over 2x cubed. So I can write individually as these fractions, right? And now I can simplify this further because x to the power 4 divided by x cubed is just going to be x by 2 minus 2. These two are going to cancel out, and 1x cancels out from the numerator, so you are left with this expression. And finally, you have 5x2, and you can write x cubed in the denominator as x to the power minus 3. Now, further simplifying, you get half x minus x to the power minus 2 plus 5 over 2 x to the power minus 3. So this is dy by dx. Now, let's find dy is going to be half x minus x to the power minus 2 plus 5 over 2x minus 3 times dx. So now y is just going to be integration of my right hand side. Alright, so now you can do everything separately. And now you can bring out your constants. And finally, you can integrate. So integration of x to the power 1 is x squared by 2, right? You raise your power by 1, you divide by your new power. And same goes here. You raise your power by 1, so minus 2 plus 1 is minus 1, you divide by your new power. Plus same here. You raise your power by 1 and you divide by your new power. And remember to add your constant c at the end. So you're going to get x squared by 4 plus 1 over x. Minus of minus is going to give you, minus of minus here is going to give you plus 1 over x plus 5 minus 5 over 4 x squared plus c. 2 times 2 here. So 2 times 2 is going to be 4. You have a negative sign, so this becomes negative here. And then this, you just write it in the denominator as x squared. And then you have plus c. So this is your answer. All right. So we have reached question D. So yeah, this is the solution. And F. All right. F basically is the same type of question. Is you have 5x squared plus 3x plus 1 divided by square root of x. All right, so you have 5x squared divided by square root of x plus 3x divided by square root of x plus 1 over square root of x. So now I can write this as 5 x to the power 3 by 2, right? Because remember, this is just half. And 2 minus half is going to give you 3 by 2, right? If you simplify this, you're going to write it as x to the power 3 by 2 plus 3 x to the power half. This is x to the power 1. You have x to the power half in your denominator. 1 minus half is going to give you half. Plus this is x to the power negative half. All right. So this is dy by dx. So to find y, you are just going to integrate your right-hand side, right? And you are going to integrate it with respect to dx. All right. So now you can just do it separately. And you can factor out your constants. You can bring out your constants from the integral sign. And finally, you can use the rule that we discussed. So you raise your numerator by 1. So if you do so, 3 over 2 plus 1 is going to give you 5 over 2. And you divide by your new power. Plus same here. X to the power half plus 1 is going to be 3 over 2 divided by 3 over 2. Plus this is going to be x to the power positive half divided by 1 over 2. And do not forget your constant of integration. Half plus 1 is going to be 3 over 2. 3 over 2 plus 1 is going to be 5 over 2. And now you can simplify. This is going to be 2x to the power 5 over 2 over 5, right? If you simplify, if you use your idea of fractions, you're going to get this answer. And I'll encourage you to think about it on your own. So you are going to get 3 times 2x to the power 3 over 2 over 3. Plus here, you're going to get 2x to the power half plus c. So because you have something over 1 in your numerator and you have this, so this fraction division is going to be the same. So let me just walk you through it, right? Let me just give you why we have this expression. So you have x to the power 3 over 2 over 3 over 2. I can write this as x to the power 3 over 2 divided by 1 divided by 3 over 2. And it's going to be the same as x to the power 3 over 2 by 1 times the reciprocal, 2 over 3. And that is how we get this expression. All right. So now that is clear. 5 and 5, 3 and 3 are going to cancel out. So I have 2x to the power 5 over 2 plus 2x to the power 3 over 2 plus 2x to the power 1 over 2 plus c. And that is the solution. All right, so that is 3f. And you can write this as square root of x plus c. And we are done. All right, so let me go to the next page. So again, for this question, I'll do A, C, and E. And for question 5, I'll do B, D, F, and H. So, sorry, let's do I, because I looks complicated. Everything else, I believe we have covered before. So, yeah, I think that should be enough because everything else looks very, very familiar. So I'll leave it for you to try on your own. So instead of 1, which is very easy, because I think A and B are quite easy, so I'll leave for you to try on your own. I'll do F. All right, so I'll do, and instead of C, I think D. So I'll do D, E, and F because those look harder. And yeah, I think that is it. I'll do C here. I think A is something we have done before. E we have definitely done before. I think F as well. We have covered a similar type of question. So yeah, for B, C, D, H, and I will do for question 5. Those look harder. All right, so question 4D. You have integral of 4 over x cubed dx. So I encourage you, the ones that I don't do, please try on your own. So this is going to be, you can factor out the 4, and it's the integral of 1 over x cubed dx. And I can write this as x to the power minus 3 actually. And that is going to be 4 x to the power minus 3 plus 1 divided by minus 3 plus 1 plus c. So that gives me 4 times x to the power minus 2 divided by minus 2 plus c. And that is just going to be minus 2 over x squared. If you simplify this expression, you are going to get this answer. All right. So that is 4d, minus 2 over x squared. So I encourage you, 4 divided by negative 2 is negative 2, and then you have divided by x squared in the denominator plus c. All right, so that is your solution to 4d. For e, you have this expression, 2 over 3 square root of x dx. All right, so now let's factor out a 2 over 3 as follows. So 2 over 3, and then I have integration of, so if you factor out a 2, you have 1 in your numerator, and if you factor out a 3, you have 1 in your denominator, and 1 times root x is just going to be root x. So now this is going to be x to the power negative half dx, right? And now, remember, x to the power negative half, you increase the power, and then you divide by the new power. So you increase the power by 1, and you divide by the new power. This is the expression you're going to get. And if you simplify this, you are going to get this expression. And x to the power half, you can write it as square root of x. So this is going to be your solution for E. And for F, you have integral of 5 divided by x root x dx. So that is 5 divided by x to the power 1 times x to the power half. And 1 plus half is going to give you 3 over 2. So this is what we have in the denominator, right? If you simplify this. So you can factor out a 5, and you can write it as this expression. And I'm going to leave you for you to try it on your own. How do you get this? So you have 5 times x to the power minus 3 over 2 plus 1 is going to be minus 1 over 2, and you divide by the new power. And just check, minus 3 over 2 plus 1 is going to give you minus 1 by 2. All right. So minus 10, because you will have this expression, and divide by square root of x plus c. That is going to be your final solution. So I encourage you to try on your own. How do you get from this expression to this expression? And it should be pretty obvious by now. All right, so we are done with question 4. Everything else, very, very similar. All right, so I will erase this. On question 5. So 5b, we have integration. I'll be very quick now. X minus 3 squared dx, right? Just expand the bracket out. You will get x squared minus 6x plus 9. If you expand it out, you're going to get this expression. And now you can do it individually. And now you can factor out if you have any constants. And remember, integral of dx is just x, right? So x, you raise the power by 1, you divide by the new power. You raise the power by 1, right? X to the power 1. So you raise the power by 1, you divide by the new power. And integration of dx is just x. And then remember to add your constant. So your final answer is just this. And we are done. (5d), sorry, 5c is the same thing, right? You are integrating 2 root x minus 1 squared dx. All right. So what happens when we square this? Well, it's going to be the first term squared a squared. So remember, a minus b whole squared is a squared minus 2ab plus b squared. So that is what we are using. This is a, this is b. All right. Minus 2, what is a? Is just 2 root of x. And what is b? b is just 1, right? So you just want to take b here. You don't care about the sign because you already adjusted the sign here. You have a minus sign here. Plus b is just 1, so 1 squared. And then you have dx. That is what you get. So now if you simplify this, you get 4x, right? 2 squared is 4. Square root of x squared is x. Minus 4 root x from my middle term plus 1. And root x, I can write it as x to the power half. So now I can write this as 4 root of x dx minus 4 4 x to the power half dx plus dx. So I'll leave you to figure out how you get here. And now 4, it's going to be x squared divided by 2, because this is 1, minus 4 times x to the power 3 over 2 divided by 2 over 3, plus this is going to give me x plus c. Right? Don't forget your constant of integration. Sorry, it's going to be 3 over 2 divided by 3 over 2. Right? You raise half by, you add 1 to half, you get 3 over 2, and you divide by your new power. And alright, so now you get 2x squared minus 8 over 3 x to the power 3 over 2, if you simplify this expression, plus x plus c. And we are done. Alright, this is the correct answer. Alright. I think, yeah, this should be it. Alright, so we are done with C as well. So I hope, if it's okay, let me erase everything. For question part D, I have cube root of x, and cube root of x is just x to the power 1 over 3 times x squared plus 1 dx. So let's just simplify. We have x to the power 1 over 3 times x squared, if I distribute this inside, plus x to the power 1 over 3 dx. Integral. Now 2, this is just going to be x to the power 1 over 3 plus 2, right? Using the laws of exponents. Plus x to the power 1 over 3 dx. And that is the integral of x to the power. Now if you add 1 over 3 plus 2, that is going to be 7 over 3. So I'm going to leave the addition to you. 2 plus 1 over 3 should be 7 over 3. Alright, so now I can integrate this individually with respect to dx. Do not forget your dx. And now you raise your power by 1. So 7 over 3 plus 1 is going to be 10 over 3, and you divide by your new power. It's going to be 4 over 3 divided by 4 over 3. Plus c. Do not forget your constant. And your final answer is going to look something like this. And we are done. So again, the algebra, the simplification, is something that you should have covered in lower classes, so I'm going to leave you to try it on your own. But this is your final answer. Alright, so question, I remember I said I would do h and I. Alright, so let's do h. I have integral of x to the power 4 minus 10 over x square root of x dx. Alright, so this is going to be x to the power 4 minus 10. X times square root of x is x to the power 3 over 2. Because this is just x to the power 1 times x to the power half, which is x to the power 1 plus half, using the rules of exponents. So yeah, I get this expression. Now I can distribute this, right? I can write it as x to the power 4 divided by x to the power 3 over 2 minus 10 over x to the power 3 over 2 dx. So now remember, x to the power 4 divided by x to the power 3 over 2 is going to give me x to the power 5 over 2. Because I will remember, I will let you do 4 minus 3 over 2. That is what's going to happen, right? So I'll let you do 4 minus 3 by 2 on your own. And minus 10 x to the power negative 3 by 2. That is my second term, dx. And finally, if I can now integrate term-wise. So this dx minus 10 x to the power minus 3 over 2 dx. Alright, so now this expression, if you integrate this, it's going to be 7 over 2 divided by 2 over 7. Add 1 to 5 over 2, you're going to get 7 over 2. And you divide by your new power, which is 7 over 2, not 2 over 7. Alright, minus 10. If you add 1 to your power, you will get minus 1 over 2, and you divide by your new power. And if you simplify everything, you should get 2 x to the power 7 over 2 divided by 7. Minus of minus, it will give you plus. And then you will get 20 over square root of x plus c. Do not forget your plus c. And that should be your answer to h. Alright, so minus minus will give you plus. divide by half is just the same as multiplying by 2, so you get 20 over square root of x plus c. All right. That is the solution to h. And finally, we have I. And that is just 2 square root of x minus 3 over this denominator. I will write it as x squared times square root of half dx, right? Sorry, x to the power half squared. Now I can further simplify this. I can write it as this expression in the denominator is going to be 5 over 2 dx. All right, so 2 plus half is going to be 5 over 2. So I'll leave you to simplify the denominator on your own. Now this is, again, a minus b squared. So that is a squared minus 2ab plus b squared. So if you simplify this using a minus b squared, and I heavily encourage you to try the algebra on your own. The algebra, you need to learn how to do it on your own. All right. So now this is just going to be integration of 4x, right? 2 squared is 4, square root of x squared is x, minus, you have 2 times 2 is 4 times 3 is 12 root x, and root x is just x to the power half. And in the denominator, you have x to the power 5 over 2, plus 3 squared is 9, and then if you simplify, if you multiply 5 over 2 times 2, right? X to the power 5 over 2 squared is just you multiply the two powers together, you are going to get x to the power 5 dx. Now we can simplify our middle term. We have 4x minus 12 half minus 5 over 2. That is going to be, right, if I simplify, it's just going to be half minus 5 over 2. That is going to be negative 4 over 2. That is going to be negative 2. So I have 12 over x squared, or I can write it as 12 x to the power minus 2 plus 9 x to the power minus 5 dx. And now I can solve this. It's going to be this expression minus this expression plus this expression. That is going to be my integral. Now I can factor out my constants. And now I can integrate. So if you integrate x, you will get x squared plus 1. Now I'll leave you to do the integration on your own because we have done a lot of examples. You will get this from your second term, right? You raise the power by 1 and you divide by the new power. And for your third term, it's the same. You will the same process. And remember to add a plus c. Indefinite integration, at the end, you add a plus c. So you get 2x squared plus 12 over x. That is going to be your middle term. Your final term is going to look something like this. And we are done with this topic, with the introduction to indefinite integrals. All right, and we are done. That is it. You're done with I. And yeah, see you in the next video.